Does listening to Mozart make you or your baby smarter? Stay tuned. Maybe you've heard that listening to Mozart makes you smarter. There are even apps that you can get that will play Mozart for your baby even before it's born. Hey, if a little is good, more is better. Let's stuff this kid so full of Mozart he won't be able to lift his head. Okay, you probably realize that a lot of that stuff is overblown and just trying to sell you things. But how did this story get started? And is there any truth to it? The short answer is, save your money. But the longer story is really interesting. That is, if you're up for a little nuance. Nuance. I wound up learning more about this than I ever wanted to know, so fasten your safety belt and bring along your favorite kazoo because it might get weird. First, let's dial in on an important point. The claim is that listening to Mozart makes you smarter. But you might ask yourself, is it just Mozart? Is it classical music in general? What's so special about Mozart after all? The short answer is we don't have time to test every piece of music ever written. So researchers tend to stick to the original piece of music for which a Mozart Effect was found. Mozart's K448 Sonata for two pianos in D major, which I'll just call K448. In fact, some of the studies I found while researching this video did include other classical music composers like Felix Mendelssohn or Philip Glass as a test condition, but for the most part the studies have focused exclusively on K448, which you can hear in the background right now. Feeling smarter? The first study on what would become called the Mozart Effect was published in 1993 in the hugely influential journal Nature. Rauscher, Shaw, and Kai played 10 minutes of K448, a relaxation tape, or 10 minutes of silence to their participants. Then, participants took a portion of the Stanford-Binet intelligence scales related to spatial reasoning. These are things like which shapes come next in a pattern, or determining which shapes would result after cutting holes in folded paper. Now, Nature is one of the top journals in all of science, the other being the journal Science. Because of this, it means anything they publish gets a lot of attention. But it also means that authors have an extremely limited space to describe what they did and why. The authors don't say why they chose Mozart or that particular piece, and they don't say why they chose spatial reasoning tasks as opposed to any other cognitive task you might think of. Because the Stanford-Binet measures IQ and is scored and normed in that way, the results from this subscale were converted to IQ scores, though that's a bit misleading because it isn't really measuring intelligence in the way the test was designed. So as is, it's not accurate to think of the results as changing IQ, but rather temporarily changing performance on one type of task. And by the way, that difference only lasted 10 to 15 minutes. I have a few other issues with this experiment. If you listen to the music, it's fairly upbeat and has a fairly fast tempo. So how did they know the result was due to Mozart raising performance on the task, or maybe it was just the relaxation or 10 minutes of silence, after all that's a lot of silence, making the scores in those groups go down? It seems to me that not controlling for tempo is a really basic experimental design flaw. For all we know, it could have been Rage Against the Machine versus those other two groups and still have found similar results. I found it really suspicious that they didn't justify why they chose this music or these tasks. One of science's dark little secrets is that there's a lot of pressure for professors to publish in high-impact journals, and there are some ways that researchers can game the system by not reporting all of the data they collected or selectively publishing results. This is sometimes known as a form of p-hacking and is one of the big contributors to the replication crisis in science that you may have heard about. How do we know that they didn't try a bunch of tasks, scales, or other measurements and only report the ones that had statistically detectable or significant results? This is a huge problem because this strategy results in false positives or results that aren't actually real. It's hard to know without more information. But before I accuse anyone of impropriety, there's another tool that science has at its disposal to help with this problem: replication. We'll get to that in a second. However, I think we can say from this first study that it probably got a lot of attention, but it wasn't well justified or designed, and although they probably did get a significant difference in the Mozart group. It goes to show that not every study published in a quality journal is high quality itself, however, and the study certainly doesn't support the claim that listening to Mozart raises your IQ. To be fair, the authors never make this claim and use the term IQ in the narrow and correct sense. It was someone else who must have come along and misinterpreted it to mean overall intelligence. On to replication. Early attempts to replicate the effect were mixed. But to be fair, there were few attempts at direct replication using exactly the same conditions and measures, but just in a different lab. That said, the lack of robustness of the effect caused a lot of back and forth between researchers and Rauscher, the lead author of the original study. In 1999, Nature published some of this back and forth in an article titled Prelude or Requiem for the Mozart Effect, which concluded with critics saying in their studies the music, quote, had little impact. A requiem may therefore be in order. I found a study from 2001 that replicated the effect but included measures to control for mood and arousal. And in that study, once you consider the role of arousal, the Mozart effect goes away. That means my suspicion is probably right. You could get a Morello effect by playing Rage Against the Machine. But here's where it starts to get weird. In 1998, Rauscher and colleagues published a study showing something astonishing. When I say astonishing, keep in mind that science requires skepticism and extraordinary claims require extraordinary evidence. Their study reported a significant Mozart effect, but this time in rats. They played K448 for pregnant rats in the days before and some days after they gave birth to litters of pups. They had control groups that heard white noise, silence, or minimalist music by Philip Glass. When these pups grew up, they learned to navigate a complex maze faster and with fewer errors than the controls. On to replication. In 2006, Japanese researcher Sachiko Chikahasa and colleagues replicated this result with special emphasis on the physiology of these rats. Once the pups grew into adults, they had higher levels of several important molecules in the brain, such as one called brain-derived neurotrophic factor, or BDNF. Now, BDNF is necessary for growth and development of the nervous system. It's important for learning and memory. It supports the growth of neurons and especially making new connections and new synapses between neurons. Now, this was published in a good journal too, one which I've published in a few times, Behavioral Brain Research. Now, rats aren't people, so this doesn't mean the same would happen for humans necessarily. But even so, what is it about this music that would change a rat's brain and its subsequent behavior for the rest of its life? In 2016, we get another piece of the puzzle. Another group replicated this effect, and they asked the critical question, what if we played it backwards? So they included 6 conditions total. Normal K448, backwards K448. They played K448, but it's all the same note on the rhythm that K448 usually has. Or K448, but it's all the right notes, but with the rhythm information removed. And then the last 2 conditions are the backwards version of the pitch only and rhythm only sample. They showed that the effect could be seen in the rhythm-only group, but not in the pitches-only group, suggesting that it's something about the rhythm of the music that makes a difference. Oddly enough, when the music was reversed, BDNF and related changes actually went down, as did May's performance. Whatever you do, don't listen to Mozart backwards, it'll make you dumber. Most of the recent studies on the Mozart effect I could find are related to its usefulness to helping manage epilepsy. Several studies have reported that it can help regulate brain activity in such a way that it helps reduce the severity of seizures. This is especially useful in cases where other treatments or therapies may be unavailable. Though the details on the best procedure are still fuzzy and need to be refined, and we need further research. But there may be some life left in the old Mozart effect after all. To me, the take-home message is that the question isn't whether or not Mozart makes you smarter. There are a couple of questions. One is, under what conditions does listening to Mozart enhance task performance? Another is, what are the properties of K448 that cause enhanced performance on some tasks? It's certainly not safe to generalize to all Mozart tunes and all types of cognition and intelligence, but I'm not going to tell you to not listen to Mozart because, well, Mozart's got some pretty fly tracks. If you found this video helpful, hit the like button. Consider subscribing to help us get psychology to those who need it and maybe a few who don't. Until next time, keep thinking. And test. Mensa, here I come.